Okay. You guys are like silent today. Who can remind me if I say the word sum, what do you know you are going to need to do in that problem? The answer to an addition problem. How about, try to bring you guys off. What if I say quotient? If you hear the word quotient, what operation do you know you're gonna be doing, Lizzie? Division. What if I say, what's the difference? Reese? Subtraction. Oh, you guys are better at this today than yesterday already. And how about product? If it asks for like, what's the product of this and this, you know you're going to what, Madison? Multiply. And kind of a newish word, but not really because you've seen it before. Variable. What's a variable? Patrick, what's a variable? Yep. Exactly. So that's kind of the thing that's changing in your number sentence. You're not totally sure what it is, but once you know it, you can solve any of the problems that they give you. Okay, we're going to add kind of a new one, but it's also probably one you've seen a million times, you just didn't realize it was rate. Okay, does anybody have any idea what a rate is? And Patrick, kind of? Kind of. Yeah, you're on the right track. Rate is where you have two quantities. Okay, often you'll see the word per. If you think of that where they say miles per hour, okay, it kind of has two quantities, and obviously the amount of time, you'll go farther. Okay, or dollars and pounds, they might say, oh, that candy is $2 per pound. Okay, we'll kind of work a little bit with that today. You can get out your. Yep, I think we're in the second one for the rest of the year. I don't think we ever backtrack. No, don't go that far. Alright, do we have them? So yesterday we kind of made rules or number sentences based on word problems. But what if they just give you a table with numbers? How could you figure out what you're doing each time? Anybody have an idea? If you look at these numbers, to go from X to Y, what are they doing each time? Can you find a pattern? If they're starting with the X and they're ending up with the Y, what are they doing each time in this table? Skylar?
Subtracting 4.
Subtracting 4. So, in our words, we're subtracting 4 from what? What are they taking 4 away from every single time? The X. Bingo. So now they give us 3 number sentences. X divided by 5, X minus 4, or 4 minus X. What are we, if we had to make a number sentence for this, what are they doing each time? Right?
X minus 4.
Bingo, right? Because they're taking 4 away from x. What are they doing in this one? That was pretty close.
Okay.
I don't know, I haven't had any turn up lately. Maybe check a couple open share pockets. Nolan, why isn't it this one? This one's really close. They're really similar.
Because we're taking x away from 4.
Yes. Bingo. That's why this one isn't right. Because we said up here, our rule is we're taking 4 away from x. But in this one, we're starting out with 4 and we're taking x away. That's not what we're doing. We weren't starting out with 1 and taking 5 away. Right? So that's why it has to be that one. Anybody confused on that?
Yeah. Wouldn't we have to do with the one more because the x is bigger?
No, because what we just said is our rule was we were subtracting 4 from x, but this one is saying you're starting out with 4 and you're taking x away. Right? But we weren't taking x away each time. We weren't starting out with 1 and subtracting 5. Does that make sense? Okay. Good question. How about number 2? You start out with q. You're going to z. What are you doing every single time? What's happening?
Adding 2?
Yes, you are adding 2 to what?
To here.
What are we adding 2 to? Q, right? Because you're starting out here and you're adding 2 to Q to end up with Z. So now they have a couple different rules. They have Q plus 2, 2 times Q, or 1/2 times Q times 1. Which of those rules match what we just said our rule was in our word? Claire, what do you think? Q plus 2, right? Because we're starting out with Q, and we're adding 2 each time. In our words, we didn't say anything about multiplying, so we knew kind of right away that we weren't going to have either of those because we're not doing any multiplying.
The third makes it look really confusing because it's half q times 1.
I know. I think they maybe did that on purpose. Okay, this one's a little bit trickier. What are they doing every single time?
I think they'll be dividing.
I think
Look at all of them. Don't just look at like the first 2. Look at all of the G's and the T's. What are they doing every single time, Olivia? They're multiplying by 4, right? 1/2 times 4 is 2. 0 times 4 is 0, so that makes sense. I mean, it's kind of weird, but it makes sense. 2.5 times 4 is 10. 1/4 times 4 is 1. 5 times 4 is 20. Okay, so we are multiplying. What are we multiplying?
4.
By 4, but what are we multiplying by 4 each time?
G.
G, right? That's where we're starting. So we're multiplying G by 4 each time. Because if you multiply T by 4, each time would we get the same G? No, it wouldn't work. So we have to multiply G by 4 each time. That's our rule. Okay, how about our rule? They give us 2 times t, 2 times g, and 4 times g. Hopefully this one was like the easiest one for you. The last one, right? Because we wouldn't be multiplying any of them by 2, because we just said right up here in our words that we need it to multiply by 4. Okay, racking and rolling, feeling pretty good? Yeah? You're very tired today.
Not really. You're about to wake me up.
You guys used up like all your energy talking yesterday, so now today you're just... Okay, you don't have this one. We're just going to do it together. No, you still need them. Now I jinxed it. I should have never said you guys were quiet today. Hang on. I just needed a lie. Okay. Yesterday we worked on a lot of number sentences. Or if you've been noticing in their book, they call them like rules. What's the rule for this information? I just want to do a little bit review. I think most of you had a pretty good handle on it yesterday, but it's kind of a big focus of this chapter, so we are going to do a little bit more of this. And the first one, they kind of throw in an extra person. Okay, yesterday we only kind of had 2 people in our situation. But Lamont, Augusto, and Mario grow carrots in 3 garden plots. So they each kind of have their little space in their gardens. Augusto harvests 2 times as many carrots as the total number of carrots that Lamont and Mario harvest. What rule could we make that would help us to figure out, no matter what number of carrots, could we figure it out? And they give you a little that Lamont and Mario harvested L plus M carrots. So who even has just a little part of maybe what this rule could be? Connor, what do you think?
L plus M.
Okay, so we already know right away we're going to need that variable, right? Because they gave it to us. So we know it's going to be somewhere in there. Sorry, Connor, I didn't put that out. Okay, and I'm going to put this in parentheses because I want to do that first. You can either put the 2 times over there, or you could put it back here. Okay, because we know whether Lamont and Mario harvested 10 carrots, 5 carrots, 1,000,000 carrots, Augusto is going to harvest 2 times whatever they came up with out of their garden. Okay? Any questions on that one? I feel like that one was a little different than the ones we did yesterday because they had 3 people in the story. No, feeling okay? Alright, how about Rashima and Alexis have a lemonade stand at their school fair. They promise to donate 1/4 of the remaining money after they repay the school for lemons and sugars. Okay. Oh, I got you. Lemon and sugar. So the girls are going to donate how many dollars? Okay, and they don't give you really any help on variables, but what variables do you know we're going to have? They kind of gave them to you in the word problem. Grace, what's a variable you're going to have?
S.
S is going to stand for what?
Sugar.
Sugar. What else do they need to repay the school for from their lemonade stand?
Lemons.
Lemons. What? So if you wanted to know how much you had to repay the school for the sugar and the lemons together, how could you figure out what operation that would be? You're right, that's another one. But what operation would I need to put between the S and the L to figure out how much money they're going to have to pay for those supplies? You're going to have to add those, right? Because let's say the sugar costs $5 and the lemons cost $5. You're going to have to add those 2 numbers together to figure out how much it's going to cost. Mason told me that M is going to be money. Money, money, money. Okay? Who has an idea how we could put these variables together to figure out how much money they're going to donate? No matter how much money they actually make, they're going to donate a fourth of that. How could we figure it out? Claire, what do you think? Okay, this is brilliant so far, right? So they're gonna have all their money. Maybe they made $100, but they still have to pay back that money that the school gave them for the sugar and the lemons. But how much of that are they going to donate to charity? Patrick? A fourth. How could you figure out what a fourth of this would be? What do we think? Divided by 4, or what's the opposite of that?
Times 0.25.
Yes. So, depending on how you feel about doing your rows, you could either take all of this and, oh, we don't put the X, right? We could times it by 1/4, or you could make a big line and divide the whole thing by 4.
Why are there these two parentheses on the S and the L and then the outside?
That's a good question. Okay, so if you remember back to our orders of operations, we always do the parentheses first, right? But if I didn't put these parentheses in here, what I would do instead is I would take 1/4 just times just this piece. So my answer would come out different and it would be wrong. Because I don't want to just take a fourth of what the sugar and the lemons cost. I want to take 1/4 of all of it. Does that make sense? That was a really good question. Okay. Any other questions on this one? This one was a little hefty too. I'm kind of stepping up my game. Can't let you get off too easy. So far so good? Can't tell if you're like success or if you're just sleeping. Both. Alright, 346. You know, we wouldn't do this down a lot of them. We should start doing some of them though.
If we do math box, we do math back
Okay. If we have two variables we're talking about, like miles per hour, what are we talking about? What was that new vocab word we had at the beginning? No, not variable. Rates. Okay, so we need to talk a little bit about rates. A plane travels at a speed of 480 miles per hour. At that rate, we want to figure out how far a plane could travel in 1 minute. Okay, how could we figure that out? If it travels at 480 miles per hour, if I only wanted to know 1 minute of that, how could I figure that out? What do you think, Grace?
Could you just take the zeros off of 180 and then an hour 60 minutes, take the 0 off of 60 and then do 40 divided by 6?
I like the way you're thinking, but we can't just take the 0 off because there's not a nice, easy 100 minutes in an hour, right? Time gets a little funky. Gotta rethink. Not 1/4. What do you think? Why would we divide 480 by 60? Because there's 60 minutes in an hour. But we only want to know one of those minutes. Okay, so they're traveling at 480 minutes over a total of 60 minutes, or an hour. But if I only want to know one of those minutes, I'm going to divide it by 60. Now this division problem might look a little bit harder than you think. But it's not. If I cover up this 0 and this 0, what am I left with?
48 divided by 6.
48 divided by 6. What's 48 divided by 6? 8.
I was halfway there.
You were on the right track. So in 1 single minute, this plane can travel 8 miles,
Wait, so that
which is pretty fast. It might not sound like a lot, but it's pretty fast.
so I was kidding, I was wrong.
No.
No, did you say that? Oh, your car can go 480 miles an hour. It is fast. I was kidding. Shoot that window all the way up.
So,
Oh, God. Oh, we'll go to the normal. We might have a time travel.
now we kind of have a new rate. We started out with 480 miles per hour, but now we know that in 1 single minute, an airplane can fly 8 miles per minute. So they're kind of nice to you. They give you your rule. Right? Because what they're saying is the distance traveled is equal to 8 times the number of minutes, right? Because the more minutes you're traveling, the farther you're going to go. They shorten that even more, right? Because in math, we don't like all those letters. We just want like one letter. So the D stands for what? Distance traveled, and the T is what? Time, or in this case, the number of minutes. Okay, so keep that in mind. What's up?
It says per.
Yeah.
Remember when you said that we're going to say per lot?
When you see per, what does that mean? What is it? That vocab word.
15 cats rate.
It's a rate. Yep. So, we need to complete the table. Now remember what I said yesterday. When we have a rule, and we want to figure it out, we just kind of plug in the numbers we know, and then we can figure it out. So for this first blank one, do we know the distance traveled? No, not yet. It's still our variable.
I know how to get it.
We have 8 over here, okay? Remember, I'm using this rule. Do we know the number of minutes?
Yes.
Oh, how many minutes are we doing right now? 3. So our distance is going to be 8 times 3, which is
24.
24. So in 3 minutes, this airplane can travel 24 miles. Yeah. Okay, and you can go through and do these for every single to figure out the distance. So the next one, we don't know the distance. That's what we're trying to figure out. We get the 8 times from our rule. What's our T in this part of the table? 4. So our distance is going to be equal to 8 times 4 is 32. Because your time is going up by 1. Yep. So I will give you a few minutes. I want you to finish the rest of this table. Remember, your rule is 8 times T. So if you just take 8 times whatever T number, it should only take you about a minute. sounds like we're already done.
Yeah.
Does your table look like mine?
Yeah. 24, 32, 40, 48, 6, 4, 32, 8.
They were all multiples
Or you could go.
of 8.
Or you could go to 34, 5, 6, 7, 8, 9, 1. Oh, I did it wrong.
Turn. I don't. No, it's right next to it. All right. We are going to graph that data that we just found. So, one thing you need to be careful about. The time is on the bottom, on the x-axis, and distance is on the y-axis. So, they don't have the first, do they? Oh yeah, they have the first one and the second one graphed. So our first one that we need to graph is when time is 3, so we find 3 under the time. And where does it need to go?
24.
24. So we need to go up. And it looks like 20. Each of these little lines is worth 2. Okay, so if we have 3, 20 gets here, 22, 24. Oh, my line didn't match up. Should be right about there. Okay, our next point is going to be where? 4. So, okay, so I find my 4 over down here on the x-axis, and it needs to go up to, here's my 30. I know 32 is going to be the next one, so I have to find where this meets 4. I think it's going to be right about, oh. Sorry guys, my marker isn't.
But it's 32. I see, it's just going to be a line.
You think so?
Yeah. It's going to go all the way to this little corner. Huh?
Okay, how about the next one? What's the next point we're looking for?
540.
5, oh, that one's kind of easy, right? So we find 5 down here, and we go up until it matches 40.
And then 6 is 48.
6 and 48. Well, it's kind of looking like it, isn't it?
Yeah, she's going to
7 and, what is it, 56?
Yeah.
2, 4, 6.
I'm just going to keep driving around.
Well, make sure
It's not going to come up.
where each of those dots needs to be. 8 and 64.
I think I skipped. Oh, no.
9 and 72. And 10.
It's just a line. It's the line of power.
9. Your 9 should be 9 and 7.
Done. Great.
Yep, there you go. And then 10 was that. Okay, I'm going to try to connect these lines. I won't make any promises because my smartboard marker isn't feeling it, but your line might be even more perfectly straight than mine. Here's a question for you to ponder a little bit. Why do you think we ended up with a perfectly straight line, diagonal line? Why do you think that happened, Olivia? Yeah, I think I know what you're saying. Yeah, you're right.
We have the same rule for every.
We have the same rule or the same same rate for every single minute that that plane was traveling, which I think is what we're. If our rule would have been, okay, at 1 minute it travels 8 miles per hour, but then after it gets going, maybe minutes 2 through 3, it travels 10 minutes. Our line would have been a little more kind of jagged. But because our rate was exactly the same every single minute that that plane was traveling, we ended up with that nice, pretty graph. So pretty. No. Okay, 348, I believe. Emily, what are we doing? This is kind of a smaller version of what we just did. Andy earns $8 per hour. What's that magical word that was just in that sentence? Per, which means it is a rate. So again, they were a little nice to you. They gave you the rule. If you take 8 times the number of hours that they work, you're going to figure out how much money he's making or his earnings. So if he works 1 hour, how much is he going to earn? $8, right? Because 8 times H. H is only 1. 8 times 1 is 8. How much money is he going to make if he works 2 hours? $16. I guess I can put my labels on. $24 if he works 3 hours.
5.
Ooh.
5.
Yeah, to kind of think a little bit backwards. If he made $40, instead of multiplying by 8, you gotta divide. So 40 divided by 8, 5 hours. And if he works 7 hours, he's gonna make $56. Okay, so let's make another little graph. After 1 hour, he is making $8. Remember, each of those little lines is worth 2. Oh, this smart card driving me nuts. 2 hours, he's making 16. 3 hours, he's making 24. Remember, be careful now. We don't have a 4, but we do have a 5. He's making $40. We don't have a 6, but after 7 hours, he's making 56. Okay, and go ahead and connect your dots. Again, your line might be a little bit better than mine. Are we ready? No. Now they kind of ask you a trick question. Makes you think a little bit more. Let's say, Andy is getting tired and he is not going to make it to a full 6 hours of work. At 5.5 hours, he has to go home. It's time for dinner. He has to go home. But how are we going to figure out how much money he makes after 5.5 hours? We don't have that anywhere on our table. Emily, what do you think?
He only worked half of an hour.
Yeah.
And for each hour, he gets $8. So just divide that by 2.
Okay. We could do it that way. What's another way?
It's $44.
Don't know what we're doing?
You can multiply it by 0.5.
You can use your rule. Okay, you guys, knock it off. Not only are you distracting to the people right around you, but to me. Okay, what do we know our rule is? What was our rule that we used to fill out that whole table?
$8 per hour.
$8 per hour. How did we write that? How did we have that in a rule or a number sentence? Allison? Multiplication 8 times what?
10 per hour.
Times how many hours, right? 8 times 8. How many hours are we saying he's working in this situation? 5.5 or 5.5. We multiply that times what? 8. 8 times 5 is 40. 8 times 5 is 40 plus 4.
44.
How many decimal places do we have in our question?
1.
1. So how many do we need in their answer?
1.
1.
44.
How many dollars is he going to make if he works 5.5 hours? $44. There is another way you could have used your graph to figure it out. Do we have 5.5 or 5.5 anywhere on our time down here? Not labeled, but where would it be if we did label it on our graph? Right in the middle between 5 and 6, right? So it'd be right about there. If we used our graph, where does this match and meet? Sorry guys, I think it's supposed to be, I'm sorry, this is my bad.
Oh, 46.
46. Are we pretty close to what our actual answer is? Yeah. So that's a good way to help you estimate. Figure out what it would be. Okay. Here is what you are going to be doing for the rest of class. Do you feel like you're ready to try this on your own?
Yeah.
Okay. You have 2 things to do. Okay, the first piece you have to do, we're going to do the first one together. What? All right, number 1. Our rule is you are going to take 15 and subtract n. Our n is the column off to the side. If I take 15 minus this n, what do I get?
Negative 14. What?
Why would I get negative 14?
Because there's 1. There's still 1 left. And 1 plus 4. Because you would subtract 15 and...
It's not n minus 15. Remember, I start out with 15, and I minus, in this case, n is 1. So I get 14. Okay, if we look at the next one, I have 15, my rule, minus, what's my n in this case? 2. 15 minus 2 is 13. Okay, they skip a few, but our rule is still the same. It still says 15 minus n. What's our n in this case? 8. 15 minus 8 is 7. Okay, they try to trip you up a little bit on this one.
10. Yeah, no, 20. 10.
Hang on. Let's walk. That's why we're doing this together. Okay. Our rule is still 15 minus, but, oh, we don't know what it is. But it equals 5. 15 minus what would give us 5? 10. Okay. So our rule is still 15 minus n. But in this case, they give us this number. They didn't give us n. So, you see how we got to this point, Jillian?
Yep.
So then you just kind of have to think to yourself, okay, 15 minus what would equal 5? And 10. And so that's why it's on this side where the other ones were. Does that make sense? Good question. I'm going to erase these just so I have a little bit of room. Okay, our rule is still the same. 15 minus, do they give us n this time? Yeah. If I have 15 and you take 18 away, negative 3.
I like keyboard.
Right, because I only have 15 and you take away 18, and that's 3 less than I have.
Last one's 15.
Okay. Mr. Anderson, if you can go. Okay, and our last one, this is kind of that reverse again. Friends, the side conversations are done. Okay, so our rule again is 15 minus n. Do we know n in this case?
No.
No, our n is up here, and we don't have it. But what do we know the answer is? 0. 15 minus what would give us nothing left over? 15. Okay, here is more jobs for the rest of class. You can do these with a neighbor. Okay, but a successful neighbor. If I have to ask you once to be on task, you are no longer going to be working with that neighbor. Okay? You are going to finish this worksheet. You are also going to do these 2 questions on page 349. Okay? When you are done, you're going to check your answers with another group. Then I want to see them. Okay? I don't think you'll get done early, but if you do, I want you to practice that B1 and B2 again. Because some of you were rushing through yesterday, and I think you could use a little bit more practice. Okay, does anybody have any questions what you should be doing? No? Alright, rock and roll.